practice problems we are about to do highlight the major skills associated with radical expressions and rational exponents. There will be vocabulary and concepts that are presumed to be understood based on you having the prior knowledge and/or having watched the previous lesson videos. If during or after this video you feel confused regarding the examples that have just been explained, then you need to revisit the previous videos and check out their examples. The examples we are about to do will not be heavily explained since the goal is to review what has already been learned, not to reteach the previous lesson videos. You need to pause this video each time there is a new question set and attempt it on your own first to see how far you can get. All right, let's begin with some Bellwork. And if you haven't started it already, pause the video, give these 3 questions a shot, and they will let you know if you are ready for the examples that are about to come. So we will talk about number 1 right now. We are looking at a 4 to the power of 3 over 2, and the only direction says to simplify. So that implies we should do a little bit of power over root rewriting to see what we would have, and that would be the square root of 4 to the 3rd power. And then 4 to the 3rd power, you might stop there, but at this stage in the lessons, we need to be simplifying things as far as we can take them. And since 4 to the 3rd power is 64, we can therefore take the square root of 64 and get a final answer of 8. So if you stopped with the square root of 4 cubed, you wouldn't totally be done with simplifying because you could go all the way to getting the answer of 8. All right, let's move on to number 2. When you see a problem that is of this style, similarly to when you see fraction problems with an exponent on the outside of the parentheses, you want to work from the inside out. The innermost part of the problem is what you would want to address first, and that would be the cube root of x to the 60th power. You would want to use, as it says, exponential form, a little bit of power over root, to rewrite it as x to the 60 over 3rd power, which is going to reduce to 20. So everything under the 4th root sign is now going to simplify to x to the 20th power. Now we can handle the outermost radical, which is the 4th root of x to the 20th. And once again, we are putting things in exponential form, so using a little bit of power over root, the 20 would go in the numerator, and then we would divide that by 4 to get an x to the 5th power, and that is the second Bellwork question. Number 3. So again, we are just simplifying, and we can possibly guess, but just like number 1, that you're going to have to use power over root to rewrite this problem. And something to keep in mind when you see numbers that are maybe a little more unfamiliar, there's usually a trick. There's usually something that's going to be a perfect 4th or a perfect 5th, which is what we have in this case, and 243 is a perfect 5th. It is in fact 3 to the 5th power, and that is a perfect 5th that you should be aware of. There aren't too many of them you got to know in terms of the perfect 4ths and the perfect 5ths, but you should know 1, 2, and 3 for the perfect 5ths and the perfect 4ths, and you will see those as we go through these examples. So, rewriting this problem, we will have the root being 5, so the 5th root of negative 243 squared. Now, you always want to try to make the number smaller before you apply the exponent, meaning the 5th root of 243 is what you would want to find first. And since the 5th root of negative 243 is going to be negative 3, that is what would go inside of a set of parentheses with the power of 2. And you might be asking yourself, why would you be taking a root and getting a negative answer? You are not allowed to, let's say, take the square of the 4th root of, I don't know, let's just say negative 16. Yes, you could have imaginary numbers and you could say the answer is 2i, but we're going to pretend like imaginary numbers are not part of this right now. But you are allowed to take an odd number root of an negative number, like the cube root of negative 8. That's going to be negative 2 because negative 2 times negative 2 times negative 2 is negative 8. You're allowed to take odd roots of negative numbers. That's the basic idea here. You are allowed to do that, but not even roots of negative numbers. That'll come up again in a later lesson, but here we go. Negative 3 is now going to be squared after taking the fifth root of negative 243. And negative 3 squared is going to be 9, and that concludes the Bellwork. So if you need to go back and listen to that again, please do so. Otherwise, we are about to do some higher level questions with all of the radical business we've been doing so far. Go ahead and pause the video when there's a new question, try it on your own, and listen carefully to the example. We have 4 of these to go through, and here's number 1. All right, now for the explanation. Notice how we are putting things into radical form, and we currently have a rational exponent. So we have to first deal with some exponent laws and then do a little bit of power over root rewriting. The power is 2, the root is 3, so we're going to have the cube root and then the entire quantity of 8x to the 4th power. Since we have parentheses around that, the power of 2 is going to be applied to the entire 8x to the 4th power. And now we can continue simplifying by squaring the 8. Remember, the 8 would have had a power of 1, so you're going to get 1 times 2, and that's going to give us 8 squared, and that's going to be 64. And then 4 times 2 is going to be 8. And now we can keep going. Sometimes you're done, but sometimes you got to keep going. We have a perfect cube. 64 is one of those numbers that you just got to know. The cube root of 64 is 4, and the x to the 8th power, we can rewrite that as an x to the 6th times an x squared. And the reason for that has been talked about in previous videos. I'm just going to assume you have watched and you have learned about how to do that procedure. So we can now simplify by taking the x to the 6th and dividing that by 3 and getting an x squared. 6 divided by 3 is 2. That's where that came from. And then the x squared is going to stay under the cube root sign, and the 4 just tags along for the final answer. There were things involving the procedure of going from the second to last step to the final answer that were not explained that in depth because it's been talked about in a previous video. So if you are watching this question and you were able to follow along for the red and the blue steps, but you got a little lost over here, that is a sign that there is something from a previous video's example that you should probably go and check out and see if you can get down. All right, here's number 2. And just so you are aware, that is a 5 in front of the entire 5th root sign. So that's a big 5 all the way in front. Take a moment and try this on your own. And all right, here we go. We are writing this in exponential form, so there should be no radical sign at the end of the problem. Let's go ahead and do a little bit of power over root to rewrite things and get rid of the radical sign. The root is 5, so when we do our rewrite, we have an x that currently has the power of 25, so we will write that with power over root as 25 over 5. And then the 2 to the power of 10 over 2. Yes, you could make that into a 5 immediately, but just to show you another way to think about it, the denominator is currently a 2, and the root being a 5, it was said in a previous video that roots live in the denominator no matter what. So that 5 could actually join the 2 in the denominator, making it a 10, and then you would have a 10 over 10 as that fraction. And the 5 would just drop down right there. But the 2 times 5 would become 10, and you would have 10 over 10, which would just become 1. So your final answer, the 5 that was in front, and then the 2 to the first power, meant to circle that one, 2 to the first power is just 2, so 5 times 2 is going to be 10, which is what you have in the front, and then the x to the 5th power just tags along for the final answer. All right, number 3. Pause the video, give it a shot. Get rid of all the radical signs. And all right, here we go. So it just says simplify, but when it says simplify, that usually means something involving the radical sign can be applied, and whatever exponent you have, something's going to be reduced. Something's probably a perfect square or some amount of variables that you can simplify. There's always something that can be reduced in a problem like this. And again, we have a perfect fourth being the number 16, a number you should be aware of, and the perfect fourth of 16 is going to be 2. 2 to the fourth is equal to 16, so that is something that we can simplify immediately. 16 is going to become that number 2. And then the power on the x is currently an 8, and you would basically divide that by 4 to get the 8 over 4th power, and that will eventually become 2 anyway. But looking at the other part of the problem, we have the power rule starting with the 1/2 to get rid of those parentheses, and 4 currently has a power of 1, so it's going to be 1 times 1/2 to give 4 to the 1/2 power. And then the x to the 6th is going to multiply by 1, and you're going to get 6 times 1 as 6 with a 2 in the denominator. And then remember from a previous video, raising something to the 1/2 power is the same thing as taking the square root of it. That's what it's ultimately going to have to be rewritten as. And since 4 is a perfect square, you would have to rewrite it as the number 2, since you're raising it to the 1/2 power. If you had a number like 10 to the 1/2 power, you would not have to rewrite it because 10 is not a perfect square. But if you had, let's say, 49 to the 1/2 power, what would that be rewritten as? Hopefully you thought 7. So moving on with the problem. The 4 to the 1/2 power comes down as a 2. The 6 to the 6 over 2 power becomes a 3, and then the 8 over 4 just becomes a 2. Lastly, the same base multiplying rule takes over for the x's, and the two 2's multiply together for the number 4, and x squared times x cubed, you would just add the 2 and the 3 and get 5. So an x to the 5th power, giving you 4x to the 5th as the final answer. All right, one more question. It might look a little intimidating, but keep in mind, it just says simplify, apply the exponent law. Some things can be reduced. There's probably a perfect fourth or a perfect fifth. Give it a shot. Come back in a moment. All right, hopefully you remembered that the power of -4/5 is going to be applied to all three of these numbers, the -32, the x, and the y. The -32 had a power of 1. That is a critical thing to be aware of. That means the -32 is getting its own exponent of -4/5. Very important part of this to understand. I'll say it once again. The number by itself, doesn't matter what number it is, let's just say the number 64, whatever, it's going to have a power of 1 if nothing else is written there. So if you have a power of 1 that the power rule is affecting, then you have to multiply those together, and that is usually a mistake that I see pop up a lot with this style of questioning. So hopefully you got the rest of it, because the other ones were just multiplying those exponents straight up. You have a -20 times a -4, that's +80, and then the denominator of 5 just tags along. Same idea with the y to the 5th power, -4 times -5 is +20, and the 5 just tags along. So rewrite things, because there's usually things that can be simplified. You have a -32, the power is -4, the root is 5, and -32 is a perfect fifth. The 80 over 5 and the 20 over 5, both of those fractions can just be reduced. And since -32 is a perfect fifth, you can take its fifth root and you will get -2 from doing that. Because -2 to the 5th power, if you put that into the calculator, you would get -32. You are allowed to take an odd root of a negative number. It's probably something we should practice in class a little bit more, or hopefully we did before you started watching all these videos. All right, we have the perfect fifth being -2, and that was the first part of that. And okay, the rest of the problem. So the perfect fifth makes the -32 become -2, and then you have the -4th power is still there. So the last thing you need to do is the negative exponent flip and switch rule. Put a 1 underneath that -2 and flip the -2 to the denominator denominator, remember, once you flip it to its other part on the fraction, you have to also make the exponent positive. Do not make the 2 positive. The 2 stays negative. It's the exponent that becomes positive. And then you can simplify things and get to the final answer, because negative 2 to the 4th power, you can absolutely simplify that to 16, and that puts a 16 in the denominator with the xy in the numerator. And again, if that question was a little too much, then it just means the previous lesson videos and those examples need to be revisited. This lesson was designed to be a higher level version of what has been talked about from previous videos. If there were things that kind of went over your head, then that just means you have a gap in your understanding and you need to revisit the previous examples. Hope this went well. I'll see you in the next video.